Now, still continuing about projectile motion, okay? Let's go ahead and go over here. Now, the projectile motion, the projectile's path it's a parabolic path, okay? It's going to form a parabola. It's going to go up, it's going to stop, and come back down, okay? Now, it has what we call 2 dimensions. And why do we say that? Do you see that obviously this object that was released or launched from this location, it has an upward path, but it also has a sideways path. Because if it started over here and ended up over here, then there goes the X component, and this going up is my Y component. Okay? So it has a parabolic path, it forms a parabola, and it has what we call 2 dimensions, okay? Those dimensions are going to be a vertical, the up and down, which is my Y component, and then it's going to have my, you can see it right here, horizontal, which is my X component. Okay, so that's the reason why you're going to hear me say the Y component and the X component. The Y component is my up and down. My X component is my side to side. Now, one thing that we need to know over here is whenever something is released, the shape of the parabola depends on the initial velocity. How fast is it going to be released is going to determine the shape of that parabola. And yes, it's going to form a parabolic shape no matter what. But the shape of how far it goes out or how up it goes high and then down depends on the initial velocity that it was reached. Okay? If we come over here and look at it this way, we can see that, for an example, this one right here has a small angle. But if you come over here and look at this top one over here, you can see over here, this one has a large angle. Okay, you can see the thetas are different. Okay, so that initial velocity is super important, and especially the launch, UNCH angle. Okay, those 2 things are going to determine that path that it's going to take. If we need to, if you know how fast, you can release it. You can go ahead and adjust that angle to determine where you're going to hit it to get it further out. Okay, get it further out or higher up, and it's going to hit closer. So let's go ahead and talk about the variables. We talked about it earlier in our notes. Again, we're just going to talk about it some more. We have our horizontal variable. Horizontal is going to be the X component. Okay, and I'm going to go ahead and put right here X component on our graph. And there are 3 variables. There is the D sub X, there is the V sub X, and then there is the T. Okay? The V sub X, the D sub X, and then there's the T. And don't forget, we have those equations that we looked at already. This equation was D sub X equals Vx times T. Okay, it was actually just the plain Jane velocity equation. Okay, that's what that is. Now let's go ahead and finish our notes over here. The D sub X is going to be the range oops, of how far it travels, how far out that way, horizontally. The v sub x is going to be the horizontal velocity. And the t stands for time. Now, on the other side is going to be the vertical variables. And the vertical variables, remember, is the y component. The y component is our d equals our v times, or our vi times t plus 1/2 a t squared. Okay, and that's part of our kinematics. Now we have the d sub y is going to be the height that that object travels. The t is the time that is going to be in the air. The a, remember, once it's in the air, what forces are acting on it? And we're talking about something that doesn't have an engine for extra energy. So if there's no forces, don't forget, we're also talking about there's no gust of wind either. Okay? The only force that's acting on it is gravity. So A stands for acceleration. But when it's in free fall, it's going to be gravity of a negative 9.81 meters per second square. And I'm going to put right here gravity in parentheses. Okay? That's why it's negative 9.81 for acceleration. Why? Because the moment it's in the air, there's no other outside forces touching it other than gravity. And then the V, 1, 2, 3, 4, the V sub I y is going to be the initial vertical velocity. Okay, so the VI, yes, the T, yes, the 1/2, the A, and then the T. And the D, we already talked about the distance. So 1, 2, 3, 4, 1, 2, 3, 4. Okay, so there goes all of my variables here. You ready? So let's go ahead and let's look at the actual path that this object's going to take. One thing is, I don't know if anybody's noticed it already, but time, there's something special here. So let me go ahead and zoom out. Time is what we call transcends direction. We're going to use time for both the X and the Y. Okay? It transcends means that it's going to be the same here as it is over there. It's going to correlate at the same time. It's going to, whatever you have on this side is going to be the same on this side. Time is not going to be independent upon the X or the Y. Time is the one thing that will always be the same. All the other numbers are dependent upon themselves. They are not independent upon themselves. Okay? What you have over here for the D is different from the D over here. What you have for the VI over here is different for the VI over here. What you have for T over here versus over here is the same. Okay, what you have for acceleration over here versus over here are two different ones. T is my only thing that will remain the same. Now don't forget this spot right here. We talked about it in our notes. We talked about it already when we had class. We called this spot right here non-zero acceleration. And what does that mean? Non-zero acceleration. at this location means that my velocity is 0, but my acceleration is still negative 9.81. Okay? Why does my velocity become 0? Because the vector arrows were in opposite direction and they start to subtract toward each other. Okay? That's the reason why. Not because, oh, and you toss an object up and it eventually comes back down because of gravity pulling on it. No, 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 no. It's because the vector arrows are in opposite directions. Now let's go ahead and look at an object that's going to be launched over here. This is the theta, okay, that is going to be launched at. And I don't know, we can pretend whatever it is, whatever degrees you want it to be. But the moment that it's released from this point, it is going to have a velocity here, and it's going to have an upward velocity or vector as well. Okay? Now, it continues to travel through the path, and let's just pretend it's over here. We always separate it into my X and my Y components. Okay? It gets to the point where it's over here, and at this point, that's where it's traveling over here, but this component right here is 0, right? It continues over here, and it's going to travel this way, my vector, and then my other vector is going to be downward. Then it gets all the way back over here, and at this point, I have a downward vector, and I also have this vector over here that's going to be at the theta or angle. Okay? So now let's go ahead and look at it and break it down, because we need to understand what's going on here. We know that our vertical, because we talked about that already. Here, my velocity is 0. My acceleration is negative 9.81. And I'm going to go ahead and put v sub y. Okay? Because that's what we need to think about it. Okay? My up and down. That's what we talked about with that little picture of the boy when he shot the gun, the bullet. Okay? So my velocity here, we're looking at the y component. My v sub y over here, let's pretend again it's 100, positive. My v sub y over here is 50, positive. My v sub y over here is going to be 50 but negative. My v sub y over here is negative 100. Now let's look at the x component, or this horizontal. My v sub x, whatever it is over here, let's just make up a number. 75. My v sub x over here is 75. My v sub x over here is 75. I thought you said, Miss Munson, is 0. Yes, in the y component. But in the x component, it will remain, look at this, the same. My v sub x over here is 75. My v sub x over here is 75. And it's going to remain positive value as well the whole time. Okay? We think of our, here's our graph right here. This is my 0, 0. This velocity in the x component horizontally will remain a positive value, but it will remain the same. Because the moment that you released it or launched it in that direction, is there any engine to force it to keep it going, like pushes it sideways? No. And so since there isn't, the velocity is going to remain the same at every single location horizontally. The velocity vertically will change. Why? Because now we have vectors that are in either an opposite direction on this half, or over here, vectors are in the same direction. That's the reason why the number here changes. Again, that negative 50 and the negative 100 does not mean numerical value. It only is going to mean direction. Okay? Alrighty. Other than that, I think all of our notes are finished and are done. Don't forget also, no matter what it is, time is going to be the same at every single location, whether it's the X or the Y, okay, at every single location. And I think there's a question like this on one of the homework pages, on page 2 of maybe homework 3. Okay, this should help you out. We are done with the notes. Make sure you get them done, turned on time.